Okay, I've had a request to explain number 2 of the problems from this worksheet, and I decided just to make a video of it because that would be the easiest way to explain it, and I'm sure someone else is going to have an issue with it as well. So let's start with number 1. It says, using Lewis dot diagrams, show how some number of atoms of magnesium and atoms of fluorine can transfer electrons to form ions of each element with stable octets. Be sure to include the resulting charges of the ions. Circle a part of your diagram that shows the formation of one formula unit of magnesium fluoride. Okay, so there's a lot there. We can break it down. Magnesium has got 2 valence electrons. Its electron structure is going to be 2, 8, 2. That means it's got 2 electrons in its first energy level, 8 electrons in its second energy level, and then 2 electrons in its third energy level. And that third energy level is the outer energy level. That's where the valence electrons are. So we draw 2 dots for magnesium. Fluorine, F, has got an electron structure of 2, 7. So the first energy level's got 2 electrons, and the second energy level has got 7. And that is its outer energy level. So I need to draw 7 dots around fluorine. There's its Lewis dot diagram, or its Lewis structure. Neither of them are stable, because to be stable they need 8 valence electrons. And how are they going to get 8 valence electrons? Well, magnesium is going to lose its 2 valence electrons. Because if it loses those 2 valence electrons, the next level is going to have 8, and it will have achieved that magic number. So one electron is going to go to one fluorine atom, and the other electron is going to go to another fluorine atom. Because magnesium's got 2 electrons to lose, and fluorine only needs 1, the electrons are going to land up here and here. So in the end, magnesium's going to have a charge of +2, and fluorine is going to have a charge of -1, okay? But there's going to be 2 fluorine ions giving you that charge. And so the fixed formula for magnesium fluoride, or the formula unit, is going to be, let me just choose a different color here. It's going to be magnesium and then 2 F's, MgF2. So that's the formula unit for magnesium fluoride. So number 2 just asks us just to visualize that if you've got at least 3 fluoride and 3 magnesium ions. So we know that 1 magnesium combines with 2 fluorides. So if I'm going to draw 3 magnesiums, and we've got the same ratio, it's a 1:2 ratio, I'm going to need 2 fluorides. And it doesn't really matter at this point exactly how you draw them. I'm just going to make sure that I've got 6 fluorides. And the fluorides have got negative charges. I've got 6 of them. Magnesium's got a positive charge, +2. And there we go. So number 3 says, what is the force of attraction that holds magnesium fluoride ions together? Would you expect the ions in the sample of magnesium fluoride to have a strong or weak attraction for each other? Well, this goes back to something we did before we went on the remote learning. And magnesium is a metal, and fluorine is a non-metal. And when metals combine with non-metals, you guys have learnt that we get an ionic bond. And an ionic bond is strong. If we had 2 non-metals combining, we would have a covalent bond, which tends to be weaker. Thanks for watching. I hope this helps, but please post any other questions that you have about this worksheet.